Hi, everybody. Welcome back to Chem 140. We are doing Unit 11 today, which is Name All the Things. And that's pretty much the whole of today's lectures. We're naming things. Important agenda items. Let's see. Lab worksheet is due tonight. That's lab worksheet number 3. I should probably say the number. That's soft deadline, so if you get in by tomorrow before it closes, it's still accepted. And quiz number 5, which went up last night. I didn't have the right number. I just put a question mark. It is indeed quiz number 5, units 9 and 10. That's due next Monday on the 24th. Or I guess I should just say Monday, since it's the next upcoming Monday. Whatever, right? I don't know how to dates. There's the number. It's on the screen. It'll be there for the entire lecture. So, all right, let's go name things. We spent a little bit of time yesterday at the very end categorizing compounds. You could see the 3 compound categories on the screen here: ionic compounds, molecular compounds, acids. Really important. A lot of the rules in these sections are real similar. So whatever it takes in your notes to separate them out so that you have a clear distinction, do so. So, like, draw a big line or go to the next page or skip a page. I don't know. Do something that will indicate to you, okay, now I am using a different set of rules for a different set of compounds. Because a lot of people tend to get mixed up when they're learning this. And then they just apply whatever rules to whatever the hell they want to. And then you get wrong answers. And Canvas is very picky about spelling, of course, right? Because it's Canvas. So be mindful of the rules and don't accidentally use the wrong rules because you will get the wrong answer. So let's get started with ionic compounds. I'm going to put the scheme on the board here. That seems like really trivial, and to some extent it is, but as we talk about the minutiae, you'll see where the detail comes in. So, name the metal. Okay, yeah, we have a periodic table handy. We can do that. Name the nonmetal with ide. Okay, that's probably not so hard. So let's go over each of these steps one at a time, just in case you aren't familiar with them, because there are some nuances that are going to surprise people, I'm sure. So the first box, name the metal, you're going to be grabbing the name off the periodic table, and depending on where that element is on the periodic table, you're going to either keep it as is or modify it slightly based on the compound you're looking at. So if your element is in these groups, it's in group 1A, group 2A, or aluminum. And remember that these are just group 1 and 2 using the normal IUPAC numbering. So going across the top, those group numbers. So group 1, group 2, or aluminum. All you do for the name is just take its name straight off the table and use it as is. The reason that we do that is because these elements have fixed charges. Sodium is always going to be positively charged. Aluminum is always going to be positive 3. Barium is always positive 2. These are fixed. A fixed charge never changes. In every single compound that we will examine, pretty much ever, sodium will always be +1. Aluminum will always be 3+. Barium will always be 2+. Calcium will always be 2+. So on and so forth. There are a few extra that sort of follow this pattern, and the text might refer to them. Those are gallium, zinc, cadmium, and silver. I'm not going to require you to know those. Sorry, just taking a drink of water there. And if Canvas asks you a question, I'll accept either the fixed or the variable charge for them. But for the remaining elements, anything else that is not one of these 3 things, group 1A element, group 2A element, or aluminum, those elements are capable of having what's called a variable charge. And so what that means is that multiple different versions of these ions exist. For example, here's iron with a 2+ charge, but here's iron with a 3+ charge. These both exist. These are both very common. Iron 3+ is even more common. It's the iron that you find in rust. But iron 2 is common enough that it will show up in various compounds that we'll explore. In order to differentiate between these two different things, we need to have a way to call them a different name. And so here's where Roman numerals come in. So I'm going to go to this page real quick. We're going to look at this in a little bit more detail. Oops, I got to zoom in first, though. So here are two compounds of iron with oxygen. Well, assuming that my pen will draw. All right. Now, if I were to just write iron oxide, that would be ambiguous, right? Which one is it? Which iron oxide are we referring to? So we need to be more specific. And the way that we do that is we have to figure out what the charges are of the things that are involved. Now, because ions follow the octet rule, if they are in groups 1, 2, or 13 through 18, any element that you find that falls into one of those groups, you know its charge. For instance, oxygen follows the octet rule, and when it's an ionic compound, it will always be like this. Remember that when we have oxygen, here's oxygen, and if I make it have its octet, I would give it an additional 2 electrons to make it have this charge. So I know every time I see oxygen in any of these compounds, it's oxygen with a 2 minus. Now, what ends up happening here is that we end up with different results when we solve for iron. So when iron is calculated here, I got to figure out what the charge is, because remember, the whole thing has to balance to be neutral. Oops, not neutrat, but neutral. So that means I have a -2 for my oxygen. I got to have a +2 for my iron. So this must be iron 2+. But over here, I have a bunch of oxides. They're all -2, so that's a total of -6. And then I have 2 irons that in order for this to be neutral, they have to sum together to make +6, right? So solving for what iron must be, each iron must be +3. And then now you can see the difference between these two. This one and this one are not the same thing, which is why you got a different formula. So we need to give them their own names so that we can differentiate them. And here's how we do that. Since iron on the left compound was +2, we're going to call it iron 2 in Roman numerals oxide. And actually, I shouldn't be circling this thing right here. I should be circling this thing right here. There we go. Because now I'm going to do the same thing. We're going to circle this one. We're going to name this one, which is Fe2O3, iron, parentheses, 3 oxide. Now, some important stuff with naming elements. We'll put this in a box here. Elements are not proper nouns. So that what that means is don't capitalize them. That's critical. If you start capitalizing names on your quiz on Canvas, Canvas will go, nope, wrong. And I'll be like, well, we said in lecture, don't capitalize them. Elements are not proper nouns. You'll notice that on the periodic table, all of the element names, even the ones that are named after people, like Marie Curie, curium, which is, where is it? CM, there it is, number 96, lowercase c. The one named after Einstein, element 99, lowercase e. The one named after France, the country, number 87, francium, lowercase. It's all lowercase. Even the one named after Julius Caesar, cesium, lowercase c. All elements have lowercase letters. Do not use capital letters when naming any elements in the nomenclature section. Ever. Never capitalize them. The only capital letters that you will use are in the Roman numerals. So these are capital. And that's it. So it's the only time you should ever hit the shift key. Also to do parentheses, because you need it to do that too. What else? When you're naming metals, there is no space between the metal name and the parentheses. So if you enter this, you'll notice there's no space there. That will be correct. But if you do this on Canvas, it will be marked wrong. Okay? Do not put a space between the metal name and the parentheses, because there isn't one. There is a space between the metal and the non-metal. So, again, this would be a correct example. Okay? Very important that you do that, because Canvas doesn't check for spelling so much as I have typed the answer in, and it checks to see if you have made that spelled exactly the same as what I have typed in. And if you have any deviation at all, whether it be punctuation, capitalization, spaces, whatever, wrong. So be careful, because nomenclature is very strict about that. Okay? So that's where Roman numerals come in. If you don't know all the Roman numerals, here they are for you. These are all the Roman numerals that we're going to be using. So the Arabic numbering system is what we use. It's awesome. It's base 10. The Roman system of numbering, well, I mean, the Roman Empire did fall. Probably has something to do with their numbers. Not that it grew too big. We're not going to go down to 10, but I'll include it anyway. So 1 is just a capital I. 2 is capital I twice. 3 is I. 4 is IV. 5 is just V. You see that Roman numerals are kind of this pseudo base 5 thing. 6 is VI. 7 is VII. 8 is VIII. And then 9 is IX. And then 10 is X. We only use Roman numerals in 3 things. One of them is the Super Bowl. Another is Final Fantasy games. The last one is naming ionic compounds. Someone had to keep the legacy alive. I suppose it falls down to Japanese RPG companies and American sports organizations and chemists. An unlikely alliance, for sure. All right. Those are the Roman numerals. If you write your Roman numerals like this, totally fine. In fact, I will probably default to doing that. You do not need the top and bottom bars. You do need the parentheses around the Roman numeral charge, though, to get credit. All right, so that's how we name metals. So remember, fixed charges, just name it with the metal name right off the periodic table. Any other metal that has a variable charge, you need to use Roman numerals with all of the strings attached. No space between the metal and the parentheses. Do not capitalize the element names. All right. What about the non-metal part? So we have this ide part. I already referred to oxide. And you've probably heard several of the element names with ide tacked on the end before. And so here are some examples of that and the difference. Ide is specifically used when you are referring to an anion. And so you can see that here. Chlorine, the atom with 7 valence electrons, looks like this. Chloride with a negative charge looks like that. Now, what are all of the ide labels for your elements? Now, this is also in your text, but we'll list those out too, just so that we can have them. And oops, I gotta click on the screen here. And so here are the elements that are going to be used commonly. So I'm going to start with, I'm starting on the right and going left. So this would be group 17. So we got fluoride, chloride, bromide, and iodide. And I'm only going to list the ones that we're going to actually use. So I'm not going to do azide because that's radioactive. You're never going to see a compound with that. So for group 16, we've got oxide, sulfide, selenide, and then telluride is a metal, so, or it's a non-metal. Not metal, sorry. It's a metalloid, so you don't really see it. So we'll just skip it. And then group 15, we've got nitride, phosphide, and then, oops, not that, arsenide. Arsenide is common enough. All right. And those are all the elements that have ions for them. And we could just quickly go fill in all the ions just so you have these here. So F minus, Cl minus, Br minus, I minus, O2 minus, S2 minus, Se2 minus, N3 minus, P3 minus, and As3 minus. There you go. So those are all the elements that have ides on there that you'll see in this class. Note that you may have heard of carbide. Carbide's actually not carbon with a 4 minus charge, which surprised me. I didn't know that for the longest time. Carbide is actually a polyatomic ion. And if you're just curious, we'll write it down here. It's actually this, believe it or not. I didn't know that for many, many years. In fact, I taught it as C4 minus, and then someone was like, hey, get some calcium carbide. And I was like, oh, what's the formula for that? And it was totally not what I thought it was. So, yeah, there you go. You're not going to see carbide, so again, don't worry about that. All right, so you've seen how to name the metal. You've seen how to name the non-metal with ide. Let's put it together. So I'm going to put things on the screen, and you're going to type them in the chat, because I know you guys are so chatty. How many people are here right now? All 2 of you. 3 of you now. So what would you call this using the naming rules that we have set up? Go ahead and type the answer in the chat. I realize I might be a little bit ahead, so I'll wait like about a minute, and then we'll just do the answer if nobody said anything. So. There you go. Very good. How did you come up with that name? Well, potassium is in group 1, so we just write it out. And this is bromine, but we put ide on the end. And there you go. Do. It seems pretty easy, And for right now, it will be, because we're just naming ionic compounds. So what do I call this one? It will get a little more challenging, though. So what do I call this one? Go ahead and type it in the chat. Wah, wah, wah. Yeah, don't capitalize it. Remember, not proper nouns. That is totally something that when you are typing, people... that's why I have to be really specific about it. When you are typing, you're going to screw that up because your inclination is, oh, it's the first thing of a sentence. Capitalize it. And it will be marked wrong. Don't do it. There's nothing quite like getting 5 out of 20 on your naming quiz because you capitalize everything. And I'm going to be like, remember that lecture or remember that part of that lecture where I said don't capitalize things? This is that part. And you'll get 5 out of 20. I won't go back and correct it. So be careful. I'm warning you now. Now you'll notice that mine's capitalized because I started it as the beginning of a sentence, and that's technically written correctly because I'm making it as a sentence, but we really shouldn't capitalize this. This should be a lowercase p. And the reason that I can justify capitalizing these is because I put a period at the end, which really what I should do is I should go through my slides and get rid of the capital and the period, because I don't want to confuse you guys. Now, if you're writing it as the beginning of a sentence, yes, you do capitalize it, because you have to use proper grammar rules. So, like, if you were writing the sentence, potassium bromide is mixed in water to form a solution, you would then capitalize the first letter of the sentence. So, I'm not going to scribble out the remaining ones for that reason, because I am phrasing these if they are sentences. But when you type it into Canvas, don't capitalize it. Anyway, type in the name of this other thing that's on the screen. There you go. Very good. Sodium oxide. Now, you'll notice here that even though there's a 2 here, we don't care in our name. And the reason for that is because whenever you combine oxygen as an anion, which would be O2-, with sodium, you're always going to have 2 of them. So we don't need to say sodium versus disodium or something like that, because you could never get any other combination with oxygen, and sodium than this one. So we just give it the name. So do not add any numbers into your name. Just name the metal and name the nonmetal with "ide." All right. How about this one? I'm going to take cobalt with a 2+ charge, and I'm going to take chloride with a minus charge. What's the formula that you get when you stick these ions together, and then what name would you call it? Type the formula and the name into the chat to the best of your ability. There you go. Very good. This is actually an interesting test to see how much delay there is. So if people are actually live, oops, not A. There's really not that much delay. I do realize that as the stream goes on, the stream will inevitably lag behind a little bit. So if I put these together to balance out these charges, I get this is my formula. And then naming this ion, this is cobalt 2. And then naming this ion is chloride. And there's your name. And you'll notice that there I did not capitalize it because it's not the beginning of a sentence, which is what you're supposed to do. You're not supposed to capitalize them. All right, how about this one? Ooh, there was thunder outside, which is funny because it's sunny currently here in this part of Everett. Oh, you beat me to my own joke. Yeah, so the formula for this, because they're both positive too, MNO, and then normally I would go PQRSTUVWXYZ. And so this is manganese 2. And then oxide. Yeah, I just looked out through the window, and I really can't see it because it's just all trees there. But I can see hints of dark clouds over there, so. All right. You guys get the idea, so I'm going to give you the samples. So I have 2 pages of these. So do these, and then after we go over those examples, I'm going to give you all the ones with transition metals. So these are the ones with fixed charges. So go ahead and name these in the chat. And then down at the bottom, we got to go the opposite direction too, which we haven't actually done. So this is your practice to do that. If I give you a name, tell me its formula. We have about 5 minutes to work on that, and we'll go over the answers together in a sec. There's the thunder again, so I guess that means 1 more minute. We'll go over the answers. All right. Let's go over the answers here. I was trying to find where the thunder was online, and it says to me it's like Silver Firs or Mill Creek. Or maybe more towards Snohomish. All right, so we got lithium here. And then O is oxide. And then we got beryllium, chloride. And then aluminum, oxide. Now, some of these elements have alternate spellings. For example, if you're British, you might spell it aluminium and put an I at the end of aluminum right here. I have programmed Canvas to accept both of those. And then this is potassium. And then, oops, that's not oxide, iodide. Excuse me. Down here, we can give the formula of these compounds. Where's my cursor? There it is. So strontium, we got to find out what charge it has. Well, it's in column 2, so to make an octet, it would need 2+. For bromide, we would need to do that. I would need 2 of this guy to balance out the total charge on the strontium, so the formula must be SrBr2. Rubidium is always +1. Nitride is always -3. I would need 3 rubidium to balance out the charge. And there's the formula. Sodium again. Sulfide. We need 2 of these. The formula would be Na2S. And then magnesium is +2. Iodide is -1. We need a second one to balance out the charge. There you go. All right, that's page 1. Now I want you to do the same thing with transition metals, which I have to word the questions a little bit differently because you need to have enough information to solve for them. So On the top, I've given you the ions that go into the compound, so you don't have to do the solving. You may have to do solving on some later examples. But using these ions shown, give the name and the formula. And then down at the bottom, give the ions that make up the molecules, but also and the formula. Give the formula too. Okay. I'll give you 5 minutes to do that. I'm going to keep researching lightning because it's fun. See you in a bit. Oh, I found the lightning. It was 2 miles east of me. 1 or 2 more minutes and we'll go over the answers to these. All right, let's go over the answers here. So for this top one at the top here, I just said that, I'm going to need 3 of these to balance out the cobalt. So the formula would be this. And because its charge is +3, its name would be cobalt 3 bromide. Same thing here, I need 2 of these to balance out the charge on the titanium 4+, so I would get TiO2. And because it has a charge of 4, I would call this titanium 4. That looks like there's a space there. Let me fix that. Oops, oxide. I'm looking at the wrong one. There we go. And then these balance out together, so we could just do CRS. Chromium has a +2 charge, so we'll go chromium 2 sulfide. All right, now we can make ions from these words. So gold 1, gold is Au. The 1 implies that there's a +1. Chloride is just that. So there's our formula. Sodium, no big deal here. Nitride, we already did this one. Barium here is in column 2. Oxide, that's an old hat. We can put those together. Platinum with a 4 here would be platinum 4+. Fluoride is F-. I need 4 of these. PTF4. There you go. That's how we name ionic compounds. Any questions in the chat, let me know. Now, those are not the only ions that you're going to encounter. You're going to encounter polyatomic ions as well. What do you do when you have polyatomic ions? Well, all you need to do is drop the name of the polyatomic ion into the box that you see. So if I was looking at, say, this, then I would just drop the name for ammonium right here. And you just ignore whatever else is there. So you don't change the name of the polyatomic ion, you don't change it to ide, you don't do anything like that. So if I had instead, say, oops, we'll just hit clear here. If I instead had this. Well, we name the metal. Okay, that's easy enough. And then CO3 with a 2- charge is carbonate. So we ignore this and we just write carbonate. Now, where are the polyatomic ions? They are on the list of ions at the beginning of Unit 6, according to this slide. I believe it's the beginning of Unit 6. Let me go double check that, just to make sure that I'm giving you the correct information. Yep, very first slides of Unit 6. You do not need to memorize them because you have that chart handy, again, online class. But if you don't have them memorized, which I suspect most people don't, go and open the slides for Unit 6, which you can get on Canvas, because you'll need them to name these. So what would I name this compound? Well, if this is potassium, and this must be this, you should go look up what MnO4- is, and you'll find out that it's permanganate. So this would be potassium permanganate. Easy enough, provided that you know your polyatomic ions. How about this one? Well, this is sodium. This must be whatever the heck this is, according to your notes, which is hydrogen sulfite or bisulfite. So we just call it sodium bisulfite. Now, if you wrote the name sodium, sorry, that's supposed to be a lowercase, but it ended up not really looking like one. And you use the other name for this, which is hydrogen sulfite. You just write it like that. There is a space between hydrogen and sulfite because that polyatomic ion has two words in its name. Canvas will accept either answer because both of those names are in common use. So here are some more of them for you to name, which is going to require you to look up polyatomic ions if you don't know them. Okay? So I'm going to give you 4 minutes to do this, and then we'll go over the answers, and then we're due for a break. See you in a bit. 1 or 2 more minutes. We'll go over the answers. All right, let's go over the answers so we can take our break. So a lot of these are going to rely on you to look them up if you don't know them. So here are the answers. So this is ammonium. This is sulfate. This is potassium chlorate. And we have barium carbonate. That should be an O. And then we have lithium, and then this is dichromate. All right. And then, again, going backwards is the same if you know what the polyatomics are. And then it's just, oops, that's supposed to be an H. Then it's just a matter of putting the charges together. Ammonium is NH4+. Nitrite is NO2 with a minus. And then potassium is K+. Phosphate is PO4, 3 minus. I need 3 of these guys. K3, PO4. All right. On these next 2 slides are just here's some more examples that you can do on your own. And then talking about parentheses, obviously you need parentheses around polyatomics if you have more than 1, or else you get something like 32 oxygens, which doesn't work out. I'm going to leave those for your practice to do on your own if you'd like. And so when we come back, we're going to start the next section, which is molecular compounds. So we'll do that after the break. Where's my clock? There it is. Let me get the music going again. We got Temple of Storms, which is appropriate given all the thunder outside. So I'll see you in a little bit. All right. Let's do covalent compounds. So, again, remember, draw a big line in your notes somewhere that will, like, or go to the next page or do something so that you don't mix these up with the previous section, because you want to keep these two separate. Because as you're going to see on the screen here, the naming scheme for covalent compounds looks pretty similar at first glance, but there are minor differences. You can see these like pound symbols. I guess we call them hashtags today. But you'll notice that instead of saying metal and non-metal, it says first element and second element. The first element is just the first one listed in the formula. The second element is the second one. You're going to name it with I, just like you did before. But we're only dealing with non-metals this time, and also we have to deal with this number thing. So, on the screen, I have treated the order of the elements in terms of their actual property. So the property that governs which goes first is called electronegativity. We don't talk about electronegativity in Chem 140. You'll talk about it in 161, though. And we'll just assume it's the more positive element. More positive meaning further to the left or further down on the periodic table when comparing the two elements. I will put them in the right order for you, so that's fine. The second element is the one that's more negative. In the boxes marked with the pound symbol, you're going to use a numeric prefix, and that numeric prefix governs how many are present in the compound you're trying to represent. Now, you only use numeric prefixes for covalent compounds. Don't start applying these to ionic compounds. You will get it marked wrong. Now, what are the numeric prefixes? Here they are on the screen. You've probably heard a bunch of these before: mono, di, tri, tetra, and then from then on it's just shapes. So penta, hexa, hepta, octa, etc. Now, you'll see where it says 1, sometimes 1 is omitted, and here's when that comes up. So if there's only one of the first element, you don't use mono. So for instance, in CO2, we would call this carbon dioxide. We would not call it monocarbon dioxide. You do not use mono on the first element, only on the second element. So if we had CO, that would be carbon monoxide. Now, these are prefixes, so you just attach them to the very front of the word, but on occasion you get combinations of letters that sound dumb and require you to make a second syllable. So, for example, with monooxide, if I was putting mono and then oxide, I would have to say monooxide, which we've apparently decided as a chemistry society that that's a little bit ridiculous. So, we get rid of the first of those two paired letters. Or in other words, you get rid of the last letter on the prefix. So mono becomes mon, and then we get monoxide. So here I have pentoxide instead of pentaoxide, so I don't have to have an extra syllable. This generally only comes up with oxygen, but there are a lot of oxygen compounds out there, so you know. And then never, never, never use Roman numerals here. Roman numerals are for ionic compounds only. Numeric prefixes are covalent compounds only. So let's do some examples here. What would I call this? Type it in the chat. I'll give you a minute to do that and to catch up. All right, hopefully you're all caught up. So we have a 2 here, so I'm going to put the prefix di in front of my nitrogen. And I have a 5 here, so I'm going to go penta. But because it's oxygen, I'm going to skip the A, so pentoxide. And again, don't capitalize these because I've capitalized them on the slide because they are the beginning of a sentence. What would I call this? I have 1 sulfur, but it's the first one, so I'm just going to write sulfur. 2 of the oxygen, dioxide. We'll just go over the answers here. I'll have you guys do the practice slide on the next one. What would I call this? Notice I put an asterisk here. You can't call it water anymore. There's 2 of them, so dihydrogen. And then we have 1 oxygen, so this is monoxide. Now, the asterisk is actually not just don't call it water. Water doesn't behave like an acid under virtually all circumstances. Water technically is an acid and a base. We treat it as a binary molecular compound for the purposes of naming. Though there is a acid name for it, as you'll find out on this next page, which is... This is a kind of a gag that's gone around the internet and has been used to illustrate chemistry illiteracy. You may have heard of the petition to ban dihydrogen monoxide. There's a website out there called dhmo.org, and it is a website that touts all of the terrible things that dihydrogen monoxide is capable of. And here are some of those, just as a fun aside. What is dihydrogen monoxide? Another name that is used for it as a common name is hydroxyl acid. And it is the major component of acid rain, believe it or not. What else does this do? It contributes to the greenhouse effect. In fact, it's a more potent greenhouse gas than CO2. We're worried about CO2 emissions, but DHMO is even worse. It can cause severe burns if you come into contact with it. If you breathe it, you will die. So don't breathe dihydrogen monoxide. Not only that, it erodes landscape. The earth just crumbles away in the presence of this substance. It corrodes metals. It causes rusting. It causes electrical failure. Your brakes are less effective when it is present. This is terrible. 100% of people who have died from cancer have dihydrogen monoxide in them. 100%, every single person. And despite all of this, dihydrogen monoxide is used in these nefarious things. It's used in industry as a solvent and coolant, which means that it gets everywhere in exhaust. It's used in nuclear power. It's used to make styrofoam, which is not environmentally friendly. It's used as a fire retardant. It's used in so many places. It's used in cruel animal research. It's used in pesticide. Even if you wash your produce, it's still contaminated by dihydrogen monoxide. It's used in junk food as an additive. And at the end of the day, it's fucking water, you guys. So, part of the point of the whole chemical nomenclature section is not just to give you the rules to name stuff, and so that you can go in and impress your friends, like, oh, I know what sodium cyanide is. Like, nobody really cares about that. But if you see it written on a bottle, you might think, holy shit, this is dangerous sounding. When in reality, lots of really common chemicals have nefarious sounding names. So don't get suckered in by the jargon, because people will try and use this to take advantage of you. Now, there are few other cases that I can think of that illustrate incompetency with nomenclature and chemistry in general than this one. I'm going to give you 2 examples, one of which is in America. Let's see if you can figure out which is the American scenario. Scenario 1 is a congressional bill was provided on April Fool's Day banning dihydrogen monoxide, and it passed the Senate or the House or Congress or whatever. And then after it was passed, everybody was in on the joke. They all then had a discussion about, oh, this is just water, by the way. Ha ha ha. By the way, you should really know chemical. And it brought to light the nature of chemical nomenclature and how very few people are versed in it. The second scenario, a radio station ran a bit, also on April Fool's Day, about how there was this compound that was in everyone's water supply, and it was called dihydrogen monoxide. And they started listing these things about it and caused a mass panic, and the station was taken off the air within the hour. And the hosts who did the bit were banned for at least a week, and they face civil lawsuits. Which of those sounds like America? I'll give you a hint. The radio station was in Florida or Georgia, one of those two states. I forget which one. This is an actual story. You can look this up. Dihydrogen monoxide radio on Google. So don't fall for chemical sounding names, because a lot of them are just common stuff that you're familiar with. All right. On the board, I have more compounds for you to name. I want you to give the names of these 4 compounds at the top, and then I want you to translate the names into formulas for these 3 substances at the bottom. And I'm going to figure out why my cat is licking his face weirdly, because he just walked in here. So type those names in the chat, and we'll go over the answers in just a second. 1 or 2 more minutes, we'll go over the answers. All right, let's go over the answers to these. So I have 2 nitrogens here. So this would be dinitrogen. And then 1 oxygen, so monoxide. For this one, I have 2 chlorines, so dichlorine. And then 3 oxygens, so trioxide. Be careful, we're so used to writing chloride, but since chlorine comes first, you'd name it as if it were just the element. Then we have sulfur, and then we have 6, so that's hexafluoride. And then for P4O10, there are 4 phosphorus, so tetraphosphorus. And then 10 is deca, but because it's oxide, we go decoxide. There you go. And then these down here are pretty easy. So di is just 2, so B2. Tri is 3, O3. Carbon is just carbon. Disulfide would be S2. And then oxygen, difluoride. There you go. Naming covalent compounds is much easier, but because it is easier, people have a tendency to apply those name rules to everything, so be careful. Only apply these rules to covalent compounds. Any questions, let me know. Let's do acids. Acids have their own set of unique rules that depend on the ending of the ion. So I'm going to give you a bunch of rules here for acids. But acids are super easy to identify. Remember, acids have H plus in them, which means that they start with H in their formula. Water is the exception. We're going to ignore water. Now, acids dissociate into H plus and then their ions. So if I had H2SO4, this would dissociate into H plus and H plus. And then the other thing is the anion. The anion is going to govern how we name this. And so if this is named sulfate off of your table of polyatomic ions, the ending of the ion dictates what you are going to do to name it. There are 3 possible endings that we can end up with. This is just showing how these split up. And we'll go over those in a second. There is something to note about the state of acids. Acids can be dissolved in water. They would be aqueous, or they could be gaseous. If our acid is a binary acid, then the state matters, and in the other cases, it generally doesn't. A binary acid is any acid that is H and then some other element. If the acid is a gas, you say hydrogen and then just whatever ide you're looking at. So this would be, as a gas, hydrogen chloride. That should be a DE, but we'll just fix it. Now, if it was the same thing, but in the aqueous state, we use a different rule, and that's this. Where it says anion stem, what that means is to remove the ide. And then you just put whatever is in there. So HCl as an aqueous solution would be hydro. We just write the word hydro. Chlor, which is the stem of chloride here. And then put ic on the end. Space, acid. So hydrochloric acid and hydrogen chloride are the same compound, but one is an aqueous and one is a gas. So be mindful of that. On the quiz, unless otherwise stated, assume that you are working with aqueous. Because it's very rare that you are working with gaseous acid anyway. You could store HCl in like a gas cylinder. It is a gas at room temperature, but all of the experiments that you will do in chemistry and at least at Everett Community College will be HCl as an aqueous solution because we don't have gaseous HCl stored somewhere. That's a huge safety hazard. There is one exception to this. HCN follows the algorithm described here. In fact, the algorithm, which isn't mentioned in your textbook, is this applies to anything that is an ion that ends in ide. Well, hydrogen cyanide as a gas will be hydrocyanic acid because cyanide ends in ide. So all of your ions, chloride, fluoride, iodide, bromide, sulfide, etc., you can name them following the scheme because they all end in ide. So that's helpful to remember. The next two schemes are very straightforward in terms of, oh, what's the anion end in? Here's the rule. So we'll get to that in a second here. Oops, I didn't mean to post the answers here. So if I wanted to name these are gaseous. So we would say hydrogen, and then whatever it is. So bromide. And this would be hydrogen fluoride. These are aqueous, so we have to do the hydroblankic acid. So this would be hydrobromic acid. And this would be hydrofluoric acid. There you go. All right, let's look at the other rules. These are for acids that contain oxygen generally. You'll notice that there are lots of polyatomic ions on your list that have oxygen in them, and they can all form oxyacids. So here are the rules for those. If your anion ends in H, you use this rule. Remove the H, and then apply ic acid to the end. So for example, so this is the ion that is present in this, because remember H plus is the other thing. This is nitrate. We're going to get rid of the H, and we're just going to put ic acid after it. There should be a space there. It's a little unclear. Let me fix that. There, that's a little more obvious. What if your polyatomic ion ends in ite? Well, instead you do this. If it ends in ite, you remove the ite, and you put us acid at the end. So if you have this is the ion that comes off because, again, remember, H plus is the other thing. This is nitrite. We get rid of that, and then we apply this other bit to it. Nitrous acid. There you go. So those are the naming schemes for acids. You just have to figure out what your acid ends in, ate or ite, or ide for the first set of rules, and then apply the correct rule. That's not very difficult to do, so of course there are exceptions that we have to keep in mind. And I'll show those in a second, after I discipline the cat. Get down from there. Get down. Oh man, he isn't even running away from the water now. He's being a pest. Alright, so what is this? If you look up what this ion is called, you'll find this word here, acetate. It ends in 8, so we get rid of the 8, and it becomes, that's without 8, we put ic acid on the end. This is acetic acid, or vinegar. Vinegar is the common name, so type in the correct chemical name on Canvas if you have this. How about this one? We just did that. How about something that contains sulfur or phosphorus? Now, with sulfur and phosphorus, so for example, with this, the ion that you get is sulfate. But if we get rid of the 8, you just get sulf. Somebody decided that sounded dumb, so we change it to sulfur. Same thing with phosphor containing compounds. So if you have like phosphoric acid or whatever, phosphate, if you get rid of the 8, you just get phos. We add the extra little or on the end here to make it sound better. So for these two examples right here, here's my H pluses. There's the other thing. This is sulfite. So we would call this sulf, get rid of the ite there. We're going to add in the extra UR to make it sound better. And then the rule. It ended in ite, so we'll call it us acid. You do the same thing for this. This is phosphate. Phosphate. It ends in 8, so we're going to have the 8 rule, but we're going to get rid of it and then adjust it so it becomes phosphoric acid. Cool. So as long as you're aware of the issues with sulfur and phosphorus when they are in polyatomic ions, that you have to change their name a little bit, this isn't too bad as long as you keep the rules straight. Alright, so here's a bunch of acids. I want you to name the acids as shown on the screen at the top. And then at the bottom, I want you to go in the other direction. I want you to turn those names into formulas for the acids, which of course is going to require you to look up the polyatomic ions and do some backwards construction here. So give these a shot. We'll go over the answers in about 4 or 5 minutes. And then we're done with naming. So I'll see you in a bit. 2 more minutes, we'll go over the answers. All right, let's go over the answers here. At the top, we have this is perchlorate, so this becomes perchloric acid. This is hypobromite, so this becomes hypobromous acid. This is dichromate. It ends in 8, so it becomes ic acid. Cyanide ends in ide, and this follows that exception that I mentioned earlier, so we would call it hydrocyanic acid. PO3 is phosphite. It ends in ite, so it becomes phosphorus acid. Note that there is an O in phosphorus acid, as opposed to the regular element phosphorus, which does not have an O there. Be mindful of that spelling issue. That'll get you on the on Canvas. Now we have to work backwards. So sulfuric acid, ic means that it ends in 8, so this would be sulfate, which looks like, oops. That's sulfate. I need enough H's to balance out the charge, so this is the formula. Nitric acid, it ends in ic, so that means this is nitrate. Nitrate, according to the polyatomic chart, is that. I need enough H's to balance it out. There you go. Again with ic, so this is chromate. Chromate is this, according to the chart, so that would be chromic acid. Hypochlorous acid, we've got us, so this would be ite. Hypochlorite, which is ClO minus. So hypochlorous acid would be HClO. And then this looks like periodic acid, but it's actually periodic acid, so be careful. This ic means that that's periodate. Periodate is that, so the formula is HiO4. There you go. That's naming acids, and that's naming everything. So that's the end of Unit 11. Any questions, let me know. Obviously not in the chat because we're about to finish, but you can always email me or message me on Discord. But hooray! We made it through the naming lecture. Oh, I clicked on a thing and the sound went away. That's okay. All right. The good news is that's another unit behind us. Probably the bad news is that there is a quiz on that unit by itself, so that needs to get announced to the, or needs to get added here. Quiz number 6 will be due Tuesday, the 25th of May. Look at how close those quizzes are due together. Plan ahead, so you have a week to do both of the quizzes. Oops, I kind of bonked into the thing here. That's okay. Let me fix that. That didn't fix it. There you go. Now you can read it. Budget your time wisely because, yes, you do have 2 quizzes that will be due within 1 day of another. And the work does start to pile up as we get towards the end of the quarter. So be aware of that. There is no lab due next week, thankfully. But we're going to start Unit 12 in Week 8. Unit 12 is the return of math, so get your calculator ready. And we are going to be doing calculations and conversions for the remainder of the quarter, Weeks 8 through 10. Units 12 through 16 are the chemical calculations that you need to be successful in 161 and mostly 162. So, thanks for coming out to the lecture. I see that there are like 2 people, so I appreciate the people that are participating in chat. So I'm not just sitting here talking to myself. For everyone else watching this afterward, make sure you stay on top of the work and have a wonderful weekend. We'll be back in here for Week 8 with Unit 12. See you later.